All right, so absolute value graphs. We're going to look at this at two different ways. Okay, we're graphing absolute value. All right, we're going to talk about the shape, and we're going to talk about how to do this mathematically and how to just look at the equation and be able to put your graph to paper. Okay, so the first thing we want to talk about, an absolute value graph has a V shape. Okay, it's shaped like a V. All right, so if I was to graph that, it looks just like a V. So for example, I'll just sketch a little graph here. Ain't gotta be perfect. An absolute value graph would look something like that. Okay, it's just a V. Boom, boom. The reason is, you think about it, what's the absolute value of -1? Is 1. The absolute value of 1 is 1. Okay, so they kind of reflect each other. All right, so it has a V shape. So what I'm going to do is I'm going to put an example down. Okay, I'm going to talk about some different characteristics of the example and how to graph that. And then we will do another example where we'll do it mathematically. All right, so look at our example. Let's say I have y equals, and I'm going to kind of spread this out a little bit so we have room to kind of take some notes. The absolute value of x minus 2 minus 4. So your equation for an absolute value graph will look something like this. Okay. Now, with this, there are different parts. Okay, so you know how in slope-intercept form, we said the second number, this was the y-intercept, the number in front of the x was the slope, and everything like that. Okay, with an absolute value function, your v shape, it's always going to, the original absolute value will start at 0, 0, and it's like up 1 over 1. Okay, over 2, up 2. Everything goes up 1 over 1 each time. Okay, and they're opposites. All right, so we keep that shape in mind. Okay, keep that shape in mind. And what happens here is these different points here tell us different things about the graph. Okay, so for example, this is -4. Whatever portion comes here outside of the absolute value, this is going to tell us which direction vertically to move graph. So in this example, this tells me to move my whole graph from here down 4. The whole entire graph is going to shift down 4. Okay, so we would say here, this example would be move down 4. Why is it down? Because it's minus. Minus tells us to go down. Okay, we're subtracting, we're moving down. Okay, so whatever number here tells us to move vertically, up or down, and how many places we move it. Okay. The next number, whatever number is here next to this x, okay, if this was vertical, this tells us where to move horizontally. Okay, so this is going to say which direction horizontally, and I'm probably going to spell this wrong, but I'm a math teacher, so it's okay. Which direction horizontally to move graph. Okay, and I'm going to star the word opposite. Okay, opposite. Here's why. This does not tell me to move the graph left to. That's what's confusing about this. Okay, -2 means I'm moving this graph to the right 2. Okay, so this would mean move right 2. So when you, whatever number in here, you do the opposite. So it says -2, well, we're going to go right 2. The opposite of -2 is +2. If it was +2, we would think the opposite of +2 is -2, we would go left. Okay? So what I'm going to do is we're going to sketch a graph. All right, so everybody, we're going to sketch us a graph, and I'm going to do it in 3 different colors. And I'm going to show you guys the movements of this graph. Okay? So, well, let me do it on this little graph here. And I'll leave that here so everybody can get that jotted down. And we're going to sketch a little graph, and we're going to move this graph. So we're going to count by ones on our graph if you're sketching. Okay? So here's what we got. And you don't have to go very far. So let's say this is -1, -2, 1, 2, 2, 3, 4, 5, -1, -2, -3, -4, -5, -3, -4, -5. So our original graph, okay, the absolute value graph is y equals the absolute value of x. Okay, this graph is it's moving diagonals, so it's over 1, up 1. Okay, it's basically starting from 0. It moves at a diagonal, starting at over 1 and up 1. Okay, and then it's going to be the opposite as well. So it's kind of reflecting each other because the absolute value, if I was to plug these in, like say I plug in a 1, absolute value of 1 is 1. So it'd be 1, 1. Okay, that's the original absolute value function. Our absolute value function looks like this. Y equals the absolute value of x minus 2 minus 4. In your example, okay, I started with the minus 4, okay, and we had that in purple. So I'm going to show you guys. So in purple, we had the -4, which means we're going to move this whole entire thing down 4. That's going to be our first movement. All right. So what I'm going to do is I'm taking this whole entire function and I'm going 1, 2, 3, 4. So I'm going to start right here. And same thing. Go on my diagonals. Okay. Going to my diagonals. We've just taken that and we've moving it down 4. All right. That's what we've done here. So we just took the whole entire thing and went down 4. That's it. The next movement was green. -2. Told you all to think opposite. Means instead of going -2, we're going to go right 2. The opposite of -2 is +2. So I'm going to take this whole function and I'm going to move it right 2. So we're going to go 1, 2, do my diagonals. You don't have to make that cool noise if you don't want to. And that, the green, is your final answer because that was our last movement. Okay, so we just went down 4 and right 2 and regraphed the entire thing. All right, so where you're starting from each time, you're starting from the origin because the original graph starts at the origin. So what you're doing with these movements is you're starting with the origin. We're going to go down 4, we're going right 2, boom, and then make your graph. Okay, so that's your movements. So when we're looking at this, that's your movement. So one thing that you can also write down with your absolute value is graph starts at origin. It's very important. Okay, our graph starts at the origin, and then we make these movements to graph it. All right. Now, some of you may be thinking, Mr. Reed, that's a lot to remember, bro. We already got a lot on our plate to remember things. Okay, that right there is just straight up confusing. Well, we can always go back and do it the old-fashioned way, mathematically. Okay. So let's do it mathematically. What we're going to do is we're going to make a table. So go back to functions. Remember we had a function rule, okay, and we made a table to give us x and y's. All right, it's the same way, okay. So I make my table. I can have my x values. All right, I can have we don't want to call it a function, but we'll have our problem here. Okay, absolute value x minus 2, absolute value minus 4, and then I have my y value. Okay, so let's just sub it in and let's see what happens. So let's say we'll just start at 0. Okay, if I plug in a 0 here with x, I just plug it in here. So it's going to be the absolute value of 0 minus 2 minus 4. Well, 0 minus 2 is negative 2, so absolute value of negative 2. Absolute value of negative 2 is 2, so 2 minus 4, negative 2. So 1 point would be 0, negative 2 on my graph. Okay. Now, obviously, hopefully you wouldn't have to show all this work, but if you do, it's fine. There's 1 point. All right. We can do another point. So we'll say this point right here is 0, negative 2. Let's do another point. Say negative 1. So we're going to take our equation here. We're going to sub in negative 1 for x, minus 2, minus 4. So what we have in here is we have negative 1 minus 2. We'll keep our absolute value. It's going to give me negative 3. All right. Keep change. And then the absolute value, we'll bring that down. Absolute value of negative 3 is 3. So 3 minus 4 is negative 1. So we have negative 1, negative 1. So my coordinate point is, oh, not 0. I was looking up there. Negative 1, negative 1. So now we can do it for another point. Let's do it for 1. And the reason why I chose negative 1 and 1 is because, again, the absolute value, remember our shape is a V, so you want to think opposite sides of each other. We don't want to just keep filling up one side because then how we know where our points are over here on the right. Okay, so if I sub in a 1, I'm going to get 1 minus 2 minus 4. Solve inside my absolute value. 1 minus 2 is going to give me negative 1 minus 4. Absolute value of negative 1 is 1, and 1 minus 4 is negative 3. So negative 3, and then my point is going to be 1, negative 3. So this is a way to substitute numbers in, okay, to get your points, and you can plot your points and then graph your equation that way, okay? So you can do that mathematically, all right? That's another way to do that, another way to look at that, if you can't remember all these rules. Now, if this is something you can remember to do, or looking back at your notes and just checking this, this is very easy to do this. Look, say, okay, I'm going to go down 4, I'm moving right 2. So you take your 0, 0, down 4, right 2, plot it, do your diagonals. Okay. Now, let's look at another example. All right, because there will be times you'll have things outside of here. All right. So we're still in absolute value. So we get example 2. All right, let's say I have y equals negative absolute value x plus 4 and absolute value plus 2. So now one thing that's different with this example than our previous example is there's a negative right here. Okay, so we have a negative. So what I'm going to do is I'm going to underline and show what each of the movements are. Okay, so again, what's going to happen here, our graph, we're going to start at 0, 0. That's my origin. All right. This number tells me vertically. Okay, vertically, am I going up or am I going down? Well, what's happening here is our graph will move up to, say, two spaces. Okay, this tells me to go up 2. All right. My number inside of here tells me to do what? Well, we got to think opposite. What's the opposite of plus 4? Well, it's minus 4. Okay, so minus 4 tells me to move left 4 spaces or units. Okay, so we're going up 2, left 4. Our graph is starting here. Nope, not quite. Okay, there's one more thing. There's a little kicker up in here. That little negative sign out there. Okay, this tells me to reflect or flip my graph over the x-axis. Okay, so we're going to reflect graph over x-axis. Okay, we're going to reflect it. All right, now reflect means we're just going to flip it. Okay, so we're going to graph this. All right, everybody got it? So let's go up and we'll go to my graph here. So again, we won't make our graph very big. So I know some of y'all probably don't have graph paper you're working with. You're just sketching it. So we don't want to make it very big. So we'll just go to 6, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay. So remember, we're always going to start at y equals absolute value of x. Okay, that's right here at my origin. And I'll show the original graph again. Okay, so you guys have a visual. That's a really bad arrow. Okay, so my first move, I said we're going to go up 2 spaces. And I'm going to do that in green. I'll color code it so we can see it. So we're going to go up 2. So if I go up 1, 2, there's my point, and draw my diagonals. That's my first move. Second move, left 4 spaces. So we're going to go left 1, 2, 3, 4. Write my diagonals. Okay, there's the second move. And the last move, we're going to reflect. Okay, the reason I say over the x-axis, we're not actually going to go all the way down here, but I want you to think that direction. Because some of you might think, oh, we're just going to flip it. If we flip it side to side, it stays the same. Okay, we're just going to reflect it. Okay, x-axis is our direction. So when I flip this, basically my diagonals are going to be going this direction. And then this is my final answer in blue. Okay, that's going to be my graph right there. It's my final answer, the blue version. So we went up, left, flip. And that's what your graph will look like. Now, again, we can do this mathematically if we want to. All we have to do is plug in points, and it'll give us a graph. You don't have to think about your directions and which way to move. Okay, I would just suggest just plugging in your numbers. Now, again, sometimes let's say if I chose 1 and -1, well, you're only going to get this portion of the graph. Okay, so it's important to know, kind of have an idea of how this graph is going to move. Okay, so always refer to your notes in that case if you need it. So this number out here is going to tell us that we need to reflect that. Now, sometimes you might have like a -2. -2 tells us we're going to stretch our graph certain ways. Okay, but then you can plug in those points and that can give you all that information there. Okay, so just to review, what we've gotten is absolute value is it's a V shape. Okay, the number outside out here tells us vertically which direction to move, up or down. The number inside of here, you think about the opposite. That tells you whether to go left and right. Okay. If you have a negative outside of here, you're just going to take it and you're going to flip it in the direction of the x-axis. Okay.